In this video, we're going to solve problems that involves density. So what is density? It's how tightly packed mass is in a certain amount of space. In order to find density, the formula is D equals M over V. So it's your density equals your mass, which is the amount of matter of an object, divided by the volume, which is the amount of space. Now, don't get confused with mass and weight. It's not the same thing. Okay, because weight is how hard gravity pulls down on an object, and mass is just the amount of matter there is in that object. So mass will always stay the same and the weight will not. So that's how they're different. Now, in order to help you with these formulas, sometimes you might have to find mass or you might have to find volume. So the best way to remember it is drawing this triangle, write DMV, and separate the way it looks. So let's say you have a problem that's asking you, oh, find mass, and you are given density and volume. So look what we're going to do. If you're looking for mass, what is left over? I have density and volume. They're right next to each other, so you're multiplying them. So it's density times volume. That's how you find your mass. What if you're looking for volume? So I'm looking for volume. What's left over? I have M and D. M is on the top and D is on the bottom. So that means you're dividing. It's mass divided by density. Now this is not just a magical triangle that works. There's algebra behind it. So for example, let's look at this one. So we know that density equals mass over volume. And let's say I was looking to solve for mass. So M is my numerator. I'm looking for mass. I want it by itself. So what's attached to the M? The V. How's it attached? It's being divided. So you do the opposite operation. So I'm going to multiply by volume. And then you're left with mass equals volume times density. So remember, you can multiply in any order, so it doesn't make a difference if the D goes first or V. So that's the reason behind it. And same thing with here. If you're looking to solve for volume, you'll be getting the same numerator and denominator as here. Okay, let's do our examples. A student measures the mass of an 8 centimeters cube block of confectioner's powdered sugar to be 4.49 grams. Determine the density of powdered sugar. So I'm looking for density, so I'm going to go ahead and use the formula. Density equals mass over volume. You just have to be able to distinguish which one is your mass and which one is volume. So for mass, you're going to see a lot of grams. And for volume, you're either going to see cubed units, you might see liters, milliliters, anything like liquid, that'll be volume. So for this case, my mass will be 4.49 grams, and the volume is 8 centimeters cubed. So you're going to go ahead and divide this. So your density will equal to 0.56125. Now for units for density, you see here that we had grams in the numerator and denominator centimeters cubed. That's how you're going to write it. It's grams per centimeters cubed. This is the units you're going to see for density in that form. All right, next question. Determine the mass of an ethyl alcohol that exactly fills a 300 milliliter container if the density of the ethyl alcohol is 0.789 grams per milliliter. I'm looking now for mass. So based on the triangle mass, I have to multiply density and volume. So I'm looking for mass. So I need my density. So that would be 0.789 grams per milliliters, I'll write it like this, times your volume. So like I said before, volume, besides seeing in cubed units, you might see like in liters, liquids. So that would be 300 milliliters. So you go ahead and multiply your numbers. So the mass here will be 236.7. Now we're dealing with mass. So you notice here, that was your density. It was grams per milliliter. So you know the numerator has to be the mass, which is in grams. And also the reason behind it is because if you put this milliliters over 1, the milliliters over here, they divide out. So they go away. But not to make things complicated, just know, just look at your units for density, so that means the numerator was it was your mass, so that's the one you're going to use, so it's grams. Which makes sense because that's the units you would use for that. For number 3, if a certain block of lead has dimensions of a 5.2 inches by 4.5 inches by 6.0 inches rectangular prism and weighs 1,587 grams, then determine the density of the certain block of lead, round to the nearest hundreds. So I'm using the density formula. So we're going to substitute our values. I have grams, that's my mass, so 1,587 grams. And now all I need is my volume. Notice in this problem I am not given any volumes at all. So that means I need to find my volume. Because it's a rectangular prism, I can use the volume formula and I'll be able to find the volume. So we're going to look for the volume of the prism. The formula is V equals length times width times height. So now we're going to go ahead and multiply what we have. When I multiply all these out, my volume is going to equal to 140.4 units will be inches, and it's cubed. So now I could go ahead and put that underneath, and I'll divide. And it says to round to the nearest hundred, so keep that in mind. So my density for this problem will be 11.30, and the units, remember, will be grams per inches cubed.